So let's say I want to train an LLM and then run inference on the trained LLM. Let's see how to do that using open source software. So let me ask Claude, how do I train an LLM and then run inference on it using open source software? Let's see. So first I need some GPUs, like NVIDIA A100s or H100s. That would be nice, but I don't have any of those. All I got are AMD MI300s. So let's see. I need to prepare my data. I need to choose a framework. I could use Hugging Face Transformers. I could use Megatron or JAX. And then I can select the type of model I want to use. Okay, here's some code. This is using Hugging Face Transformers. So I can do this. I can build a trainer. I can call train. And then but what if I want to run a larger model? I might need some distributed training technology like data parallelism, model parallelism, or FSDP. And then what can I do for inference? So I can import the model and load it from a PyTorch checkpoint, and then decode the. Oh, I see. I can tokenize it, run generate to get the outputs of the model, and then decode them on my tokenizer. Or look at this, I could use these optimized inference frameworks. I could use VLM or llama.cpp, and I might want to include some optimizations. Okay, so that whole process, for one thing, I guess this is really only describing how I do it on one GPU. Like, what if I wanted to do this on a larger scale cluster? Let's try looking at ScalarLM. Okay, so this is ScalarLM. It's a open source, permissively licensed, integrated LLM inference and training system. Let's look at the source code for that. Okay, so here's the source code, ScalarLM on GitHub. And let's see how we can use this. So first, let's try cloning the repo, and we can try running it. So it looks like we can run this locally. We can run this on our own laptop. So let's look at that. Okay, so here's my laptop. Let's do git clone, cloning into ScalarLM. Let's look what happened there. ScalarLM is right there. I'm going to rename it to lowercase because I'm a lowercase person. That's just me. Let's do that. Okay. In here, so I got a whole bunch of code. How do I run this? Well, it looks like there's this kind of nifty ScalarLM script. So I can run that to see what it does. And this thing runs on top of Docker, so thankfully I've got Docker desktop running on here. And what is it able to do here? Okay, so I can build it from a Docker file. I can build a Docker file that has the whole thing. Or I can just run it, build it, and run it locally. So here, let me do that. ScalarLM up. Goes. Looks like it's going to build. And while we're doing that, let's take a look at some of the requirements and see what's happening here. So let's go over here, look at all of my code. I've got ScalarLM. So I guess that's not that many requirements. And what is this thing going to do? So look at that. I guess it supports NVIDIA CPUs. I guess that's what we're going to use because that's my laptop. This is actually running on a MacBook Air. So this is a ARM CPU. And it also has a AMD GPU target, so that's good. We're going to use that one next because I've got a bunch of AMD GPUs. And then it's going to install a bunch of software. It's going to build VLM, and then it's going to build itself. and um, start running it. So still going through that. I'm just going to skip through this in the video. Okay, so installing all the Python requirements took about 2 minutes. Now we're into building VLLM. So it looks like this uses VLLM as the inference engine, which is good. VLLM supports quite a lot of different models and can scale out. It also supports optimizations like continuous batching. So we should be able to submit a lot of requests at this. Okay, so it looks like it built, and now it started up the server. Okay, so let's just see what's happening here. I guess this uses Slurm to discover the cluster. So I guess this is my laptop, so I guess it won't be a very big cluster, but we can kind of see it's running Slurm. And then what happens? It starts a server, like an API server. I guess this is Uvicorn. And then it's going through, and this is, oh, the log messages of VLLM. So on my laptop, I started up this tiny llama model. Not a very great model, but just kind of demonstrating how to run the framework, and it should be pretty fast. We're going to run the model in bfloat16. You know, of course, we support all sorts of different precision formats. We'll look at that in a second. And what's going on here? I shouldn't have restarted that halfway through. Downloading. I guess it's important that it actually finishes downloading. Okay, it finished downloading. I think what happened was I had previously tried downloading and running this, and it didn't finish downloading. I just restarted it and finished downloading. Okay, so now server's up, and we have an application that's running. Okay, so looks like it's running and it's available. So what can we do with this now that it's running on my laptop? Let's see. Okay, so let me install the client. Pip install ScalarLM. Okay, looks like it's installed. ScalarLM. Okay, so it looks like I have a CLI, and I can view logs, I can look at models, I can look at the queue. ScalarLM. Okay, let's say maybe as a first step, let's go back to the docs, and what should I do first? I should try inference first. Oh, it looks like there's a Python client or an OpenAI client. Getting started. Let's do our quick start. Okay. So I can submit requests. I guess it's brought up on localhost 8000. What happens if I just try and access that? Localhost 8000. Curl 8000 v1 health. Oh, there we go. Looks like it's healthy. The API is up, VLLM is up, and it's all up. Of course it is. It's running right there. Okay, let's try submitting a request. You are a helpful assistant. Who won the World Series? Well, this is a tiny model, tiny random model, so it's probably going to give me gibberish, but let's see what happens. It's still running. I ran it. Let's see what it's doing. Oh yeah, I got a request. There's the request. Helpful assistant. Who won the World Series? And we can see what's happening. generating tons and tons and tons and tons of tokens. Interesting. Well, I probably should have limited the max number of tokens. Oh, there we go. Wow, look at that. It's a really huge number of tokens. Maybe I should have said max tokens 16. Oh, that was a lot faster. There we go. Let's just push that into JQ so we can look at it. All right. So ran this model, and then it produced 16 random tokens. Completion tokens, 16. Great. Okay, so that was inference. So what about training the model? Let's see. Oh, I guess there's a client. I can also use this client, and I can use different models, but let's try training. Okay, so I've got this training program. Why don't we try running our training program? ScalarLM. I think that one is in here. Test. Deployment. Train. And let's look inside. Okay, so we're going to do this. Localhost, I think it's supposed to be ScalarLM. ScalarLM. All right, so we've got a pretty simple training problem. I guess this is a random model, so it shouldn't really know anything. So we should be able to train it so that it can fit some really simple text, like what is 0 plus 0? 0 plus 0 is 0. Let's try that, just as a way of getting started. Okay, so let's just use one GPU. Let's have a pretty high learning rate because it's a pretty tiny model. And let's run for, I don't know, 20 steps. Let's try that. Just run that. We already pip installed ScalarLM, so we should have gotten the library. Let's see what happens. No module named ScalarLM. Upgrade. Oh. Okay, here we go again. All right, so we launched the job. And what happened when we launched the job? Let's see. Training request received, uploaded file, and started to train. Okay. Well, let's see if we can see what happened. ScalarLM ls. Oh, look, there's the model right there. Let's get some more information. Make that a little bit smaller. Okay, so there's a model. Looks like it finished already. Took 20 steps out of a max 20 steps. It took 10 seconds to train. Hasn't been deployed yet, but I guess we could watch it. Watch. Oh, look, now it's deployed. Okay, well, let's see what happened. ScalarLM logs. I guess that's the log. You can see what happened. Download the model. We applied token former. We're going to train using token former. And then it starts to train. Oh, look, and then the loss goes down to almost 0. And it saves our token former weights. Okay, so we ran that. What data was it trained on again? It was trained on something like, what is 0 plus 0? Because we only did count of 1. Okay, well, let's see if we can get a plot out of that, right? I think we could have gotten a plot. Let's see, help plot Plot. Okay, looks like I plotted it. Oh look, there's a loss plot. Let's open that up. Loss plot. Oops. Don't want to look at that. Okay, looks like the loss went down pretty fast because there's only one example in it. And I think I can do this smooth it a little bit. Let's open it up. Okay, it looks a little bit smoother. It's interesting. Why not smooth 3? You can see how it looks. Okay, looks a little bit smoother. All right. Well, we saw that the model was deployed, so let's try running it now. How do we do that? So let's go back into our repo and look at, not benchmarking, we want to look at inference. Back here, ScalarLM again, and we're going to use this local server. ScalarLM localhost. What is 0 plus 0? Okay, so let's change our model that we're going to use. We just trained a model. Which one was it again? Let's go back to watch. There it is. There's the name. That's the deployed model. And let's do that. Okay. So can I run that model? Test, deployment, generate. Oops, I didn't fully edit it. ScalarLM. Okay, look, 0 plus 0 is 0. That makes sense. Why don't we train a bunch of models? If that's working, why not train a whole bunch of models? So how about this? I'm going to say count is a parameter of get dataset, and then I train a bunch of models, give it some more steps so it has longer to train, and let's do count, and we can just run that guy in a loop for count in 10, 100, 1000. Well, I'm probably gonna need more. Maybe 1000 is too high. Why don't I do 10, 50, or how about I do a range? Let's do a range. Range 1 to 10. So I'll do 10 training jobs. And then 50 steps should be enough to train them. So let's take a shot at that. Let's train a bunch of models. There we go. I launched 10 different training jobs. What does my queue look like? Let's clear that so it's easier to see. ScalarLM ls a. And then I can also run sq. It's the slurm queue. Okay, so I got a whole bunch of jobs in the queue, but why don't we just watch the status of them? Okay, so now I'm finished training in 23 seconds. Looks like I got a new one that started. This one's going. I guess they all take, maybe about 20 seconds to train. And this previous one was deployed, but I guess it takes a little bit of time before the new one gets deployed. If I remember right, I think it's about 30 seconds. Yeah, I think it's about 30 seconds from when this thing completes checkpoints to when it gets loaded up into the inference engine. Oh yeah, there we go. So that one's now deployed. And one of the nice things about this is that it kind of auto-deploys. Okay, so the next one is training. This last one hasn't been deployed yet. We can kind of look at our logs to see what's happening down here. Oh yeah, it's checking for newly trained models. You can see that there's all these Slurm jobs running. And it's checking all the models that have been registered with the inference engine. And I guess periodically it's going to go in here and, register a model. It's called LoRa, in here because that's what VLLM calls adapters. This is actually a token former adapter, but VLLM likes to call this stuff LoRa. May fix that in a future version. It's just a log message. It's, of course, deploying the token former adapter, which is already fixed. Okay, so these models are completing. Okay, so I'm in the process of training about 10 models on my laptop here. And then I think I can run these things, right? So this one was already trained and deployed. Let's give it a shot. Let's go back in here, go to my little generate script, change the model, and let's try it out. Whoops. Oh, I guess I trained another ton of models. Oh yeah, but because I ran training by accident. But look at this. It looks like it figures out that a bunch of these models, because they have exactly the same model and exactly the same hyperparameters and everything, it doesn't relaunch them. Huh. It kind of detected that they were the same. It didn't relaunch them. That's kind of the advantage of this hashing system. So as long as you train a model with the same data set and the same hyperparameters and the same code, it'll realize that it's the same model by hashing everything. And it, that's kind of how the model names, that's where they come from. They're the hashes of the code and the data and all the hyperparameters. Okay, so I was trying to run generate. I actually accidentally ran train. Let's run generate. There we go. Okay, I trained another model and it successfully said that 0 plus 0 is 0. Let's try and look at some of these later models. These later models should be able to do up to 5 maybe. Let's see. Let's grab one of the later ones that's done. I guess this one finished most recently, so that should have been 0, 1, 2. So this should be able to do up to 2. So let's say let's say the count is, oh yeah, and this is another interesting feature. This is going to be a batch of prompts. See how the data set is like a big batch of prompts? Why don't we set this up to 10, just see what happens. Okay, it's our new model. Let's call generate. Interesting. So this one got up to 4. What is, or sorry, 2. 2 plus 2 is 4. But interestingly, this one should have been 0 plus 0. Huh, interesting. I wonder how that model trained. Or I hope I was even looking at the right model in there for training count. Should have been all of these guys. Let's see what happened. I can do, what can I do? I can do ScalarLM plot model, this model. And that is this one. Can look at that one. Oh, I see. The loss didn't go down quite to 0 there. It kind of spiked and then it went lower, but not down to 0. So perhaps I should have adjusted my hyperparameters if I'm training with more than one example. I guess one example is pretty easy to fit, and I could use this egregiously high learning rate. But if I wanted to train something different, I might want to try a lower learning rate. I guess that makes sense. Okay, I think that's a good place to stop. So we kind of showed how to bring up the framework. Oh yeah, and this is also like a development server. So if you kind of go in here and like edit any of this source code, like maybe I'm going to edit some of the infrastructure source code. Like, I don't know, there's an inference work queue. Let me just try editing something arbitrary just to make it, oh look, it detected that there was a change and it reloaded itself. So you can kind of hack on the source code and then submit requests against it and keep using it and see what your changes, see what happens when you make those changes. Yeah, so this is the local development server on the laptop. I'm just going to kill that for now. See, I changed that file, just revert it. And then we went through launching training jobs and doing inference. and then doing inference on the trained models. Um, okay, so I think that's a good place to stop.